Well, you've learned about properties of parallelograms, and now with this video you'll use those properties to solve for some of the missing lengths and angles. You should be on page 6 of your packet. What is the measure of TU? How do you know? We look at this figure. It's been labeled with arrows that indicate parallel lines. Because it's a parallelogram, TU is parallel to ST. It's also congruent, and so the measure of TU is 12. What is the measure from W to T? How do you know? Another property of parallelograms is that diagonals bisect. And they bisect, that means that they're equal measure from the middle. So the other portion of this line is 14, and WT will be this congruent. It will also be 14. What is the measure of angle L? The third property about parallelograms is that consecutive angles are supplementary. When you subtract 135 from 180, you get 45 degrees, and that is the measure of angle L. You might want to set that up for yourself, do your own math, make sure this is correct. What's a fourth property of parallelograms? We'll use that to solve for the measurement of angle J. Angle J is opposite angle L, and so the opposite angles are congruent. Therefore, the measure of angle J is also 45 degrees. What is the measure of angle K? How do you know? Angle K is opposite angle M. So if M is 135 degrees, K will also be 135 degrees. Add up the four interior angles of parallelogram JKLM. What measures do you get? You get 360 degrees, because 135 plus 45 plus 135 plus 45 equals 360. What can we conclude about the measure of the interior angles of a quadrilateral? Since the measure of the interior angles of a parallelogram is 360 degrees, the measure of the interior angles of quadrilaterals is 360 degrees, because parallelograms are a form of quadrilaterals. Solve for x. How are we going to set this up? Looks a little bit like algebra because there's a variable, but you know what to do. We'll set this up where we have 9x plus 2 is going to be equal to 12x minus 34. This is an equation, so it's equal, not congruent. I'm going to subtract 9 from both sides. I'm going to add 34. These cancel out, these cancel out. I get 36 equals 3x. 36 divided by 3 leaves me with x being equal to 12. Right? Now I'm going to clean this up, and I'm going to solve for the actual angle. I want to put this x to use. X was 12. So 9 times x times 12. Clear that up. 9 times 12 is 108. Plus 2 gives me 110. That is my angle measurement. Let's put it to use. And the other angle, 12 times 12 is 144, but you knew that, minus 34 equals 110. Our opposite angles are congruent. Now, what is the measure of angle B? If we know that A is 110 and consecutive angles are supplementary, 180 minus 110 quickly gets you to 70 degrees. What about the measure of angle D? The next property about parallelograms is that opposite angles are congruent. If B is 70 degrees, then D is also 70 degrees. Decide whether the figure is a parallelogram. If it's not, explain why not. You see two angle measurements of 117 and 64. You add those two, you get 181. That's beyond supplementary, and therefore the first shape is not a parallelogram. You might want to mark that as no or not. These numbers are 181, and that's too much. It's not a parallelogram. Are the opposite angles congruent? I could make a congruent sign here and say, nope, they're not. This is not a parallelogram. On my fourth example, are the sides, the tick marks, the same? Does that mean that opposite sides are congruent? Yes. So this is a parallelogram. Use the diagram of the parallelogram ABCD at the right. AC is perpendicular to BD. What is the measure from A to E? By the property of diagonals bisect, AE will be 3. What is the measure of AD? The property of opposite sides are congruent. AD is 5. What about the measure from E to B? This is a little tricky. You have to use the Pythagorean theorem. We know that that's a right triangle because if the lines are perpendicular, then all of those angles will be 90 degrees. 5 is the measure of the hypotenuse. 3 would be the measure of one of the legs. 5 squared, 25, minus 3 squared, 9, equals 16, and the square root of 16 is 4. So the measure of EB is 4, And back to diagonals that bisect. The distance from D to B would be 4 plus 4, which is 8. So we have 3, we have 5, we have 4, and we have 8. This is a parallelogram. Find the lengths and angle measures. The length from A to D, we look across to the opposite side, which is congruent. AD is 8. What is E to C? Because diagonals bisect, it will be 5. We have 8, we have 5. What is the measure of A, D, and C? We look to the opposite side from angle D, which is angle B. 65 plus 45 is 110. ADC will also be 110 degrees. The measure of angle B, C, D. The property of supplementary angles means that angle C has to be 70 degrees. Okay, moving on. The value of each variable in the parallelogram. D is opposite 10, so that's what D would be. E is consecutive to 90 degrees, so E is also 90 degrees. Our next example, A is opposite 15, so it is also 15. Angle B is opposite 135 degrees, so it is congruent, and it is 135. Using these properties over and over again. Find the value of each variable. You have X and Y. Okay, you're going to put in your answers on your own. And you look at the next parallelogram. Variables for A, B, and C. Okay, we have some more variables. D will be supplementary to 182. Subtract 82 from 180. E will be congruent because they're opposite angles. And F will be 82 because they're opposite angles. This last one, G, H, I, J. I'm going to let you do that on your own. I think you can find those measurements. And you have time for independent practice. Find the value of each variable in the parallelograms at the bottom of page 8. Keep up the good work.